Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can prove that if two parallel lines are cut by a transversal, that alternate interior angles are congruent. So in this case, we were given the picture where we have line P and line Q, and they're cut by the transversal T, and we want to prove that angle 1 and angle 2, which are alternate interior angles, are congruent. So where we're going to start is always with our given. So let's set up our two-column proof here. So we've got our statement and our reason. Now, as we look at this, we want to start with what we're given. So we're given that P is parallel to Q and cut by our transversal T. Now, this is super important because based on this, we can use other theorems that talk about angle definitions. And so the very first place I want to start with are saying that angle 1 and angle 2, or not angle 1 and angle 2, ooh, that's wrong. Angle 1 and angle 3 are vertical angles. Now this is super important because notice how they're straight across from each other. And we know that they're vertical angles by the definition of a vertical angle. Vertical angles are angles that are right across from each other. Perfect. Now, our next part that we know is because they're vertical angles, we also know that angle 1 and angle 3 are congruent to each other. And that is by that vertical angles theorem. And we just proved that in the previous video, which is why it's so important that we learn these so then we can use them. So we've proven that the vertical angles theorem is true. Now, with that being said, we also know that angle 3 is congruent to angle 2. The reason why is because of the corresponding angle theorem. Now, this is not something that we're going to prove in our class, but the corresponding angle theorem is proven to say that corresponding angles, so on the same side of the transversal, in the same relationship between the two parallel lines, so both on top of the parallel line and on the left of the transversal, in this case, they are corresponding, meaning that they're congruent. And that's what that corresponding angle theorem says. So those are congruent. Therefore, if 1 is congruent to 3 and 3 is congruent to 2, then angle 1 is congruent to angle 2 by the transitive property of congruence. So the transitive property of congruence tells us that if I have two things that are congruent, so if A is congruent to B and B is congruent to C, then A is congruent to C. So in this case, if 1 is congruent to 3 and 3 is congruent to 2, then 1 is congruent to 2. And so that's so awesome that we were just able to prove that alternate interior angles are congruent based on the definition of vertical angles and using that corresponding angles theorem. So please check out the next video in which we explain how the interior angles of a triangle all add up to 180. Now, just as a quick preview, when we do that, we do have to create two sets of parallel lines. And those parallel lines, we actually end up using our alternate interior angles to determine what things are congruent.